Okay. So hi, good evening. Can you hear me? Hello.
I can hear.
Hello, can you hear me? Okay. Okay. So we will start our today's class. Okay. 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 Now can you see my screen? Okay. Can you see my screen? Okay. So hi and welcome to the 3 days online training program for remote sensing analysis using the Google Earth Engine platform. So basically today is our third day. Okay, and I am course coordinator. So basically this third day course coordinator will be that I will try to discuss about that. First of all, how we can do computation using satellite images. This topic we already covered our previous class. So different types of band calculation we will try to discuss about this. Mainly today I will try to first of all try to discuss about the introduction to land cover classification. So how we can easily make the land use and land cover classification map using the Google Earth Engine platform. We also try to discuss about this topic, and then how to make the LULC map using the Google Earth Engine platform. Then how to export this map as a TIFF format, and then we also try to discuss about the air quality monitoring using the Sentinel-5 satellite images. And then we also try to discuss about that how can easily filtering and displaying the Sentinel-2 satellite imagery, and using the Sentinel-2 satellite imagery you can calculate the NDWI. Okay, so let's go. So first of all, introduction to land use and land cover classification map. So basically this land use and land cover classification map is that we can easily define as the observe the biophysical cover of the earth surface. The land cover is the totally natural feature, and land use is the human made feature in the earth surface. And we can, using the land use and land cover classification map, we can easily document the what is the change of the land use trends. We can easily identify using the land use and land cover classification map. Just a minute, I think some person also join with this. I simply approve this. Just okay. Okay. So basically, this is the observe the biophysical cover of the Earth's surface, and land cover. This is the natural feature, and land use. This is the human-made feature. So basically, when you want to work with the make the land use and land cover classification map using the Google Earth Engine platform, we need to follow the some step. Okay. So this step is that very easy, and when you want to make any land use and land cover classification map, we can just follow all of the steps. Then we can easily create the land use and land cover classification map. So first of all, you need to selecting your ROI or region of interest. Okay. Suppose you want to make the land use and land cover classification map for the Dhaka city region or Kolkata city region or whole country boundary of India. Okay. So first of all, you need to selecting your ROI or your region of interest. You need to select your ROI. You can easily import your shapefile and you can select your ROI. Okay. Then you need to choosing and filtering your image collection. It can be Landsat or it can be Sentinel. Okay. So you need to choosing this image and then you need to filter. And previous day class, I also try to show you that how you can easily filtering the Landsat 8 satellite imagery. Okay. So you need to choosing and filtering the image collection. Okay. So after this, we need to collecting the some training point. Okay. So you need to collect the some training point from your satellite imagery. If you have your ground truth data, then it's also okay, no problem. You can easily use the ground truth data as a in Google Earth Engine platform as a training data point. Okay. So you can easily import your training point as a shape file in Google Earth Engine platform and working with the ground truth data for as a training point. Okay. Or in this time, I also try to show you that how you can easily get the training point from the satellite images. After collecting this, you need to merging all of the training point together. So you need to simply merge all of the training point together, and then you need to make a training data set. Okay. So in this time, when you want to take the training point, we collect the spectral signature of each training point. Okay. We collect the spectral signature or band value for each spectral signature. We want to for the every point we take the make the training point, and this training point we need to collect the make the all of the band value. Okay. And then we need to create the data set. Okay. So this is our data set, and next time we just make a classifier or create the classifier and classify the image using the data set. Which data set I want to create? Okay. This is the spectral signature we create or band value for every each point. Okay. Then we need to create the classifier. In this time, Google Earth Engine has a lot of classifier is available here. If you want, you can use the random forest. If you want, you can use the classification and regression trees. But in this time, I also try to show you only for the one classifier. This classifier is the classification and regression trees. How you can easily make the model using the classification and regression trees algorithm, and then how you can easily make the classify image. Okay. Then create the classified image and then display the result. After this, you also need to calculate the specific area of each classes. How many all of the class you need to calculate the area. And after this, you can simply make the accuracy assessment. What is the accuracy of your map? Okay. So basically, this is the step when you want to make any land use and land cover classification map. First of all, you need to import your region of interest (ROI). Then you need to choosing and filtering your image collection. It can be Landsat or Sentinel. From the satellite image, you need to collect the training point for individual classes. You need to collect the training point for the water. You need to collect the training point for the urban area. You need to collect the training point for the vegetation. You need to collect the training point for the barren land, like this. And finally, you need to merge all of the training point together. You need to merge all of the training point together, and then you need to make the training data set. Basically, this training data set is the spectral signature value or band value. For each point, you can get all of the band value. Okay. After this, actually, this is the data set. Okay. Then we using the data set for train our model. Okay. In this time, there are the different types of classifier are available for train the model. in this time I also show you only for the one model. This model is the classification and regression trees, and then classify the image, then display the result, then calculate the specific area of each classes, and also try to show you that how can easily make the your model is the good or bad. We also need to check the accuracy of this model. Okay, so we also make the accuracy assessment of this map. This model is the good or bad. We also try to calculate the accuracy assessment using the we can easily use here the confusion matrix table, and from this confusion matrix table we can calculate the overall accuracy of this map, of this model, which model I want to set in here. Okay, so in this time I simply open my code editor, then try to show you the all of the things step by step so that you can easily understand. Also you can see this is the another map for the land use and land cover classification map for Sagline sub-district of Bangladesh, year of 2017. And also you can see this is the code link. So, and we also add here the legend or title or like this. So I also try to show you that how you can easily add the legend in Google Earth Engine platform from this code. I also try to show you this part for how you can easily add the legend. Okay, and also you can see this is another map for the land use and land cover classification map for the Dhaka city. Basically this map is also created in Google Earth Engine platform, and we can easily classify the built-up area, water body, vegetation and barren land. And finally we also try to calculate the area, how many built-up area is available here. You can see built-up area is the you can see a lot of built-up area is available in here. Then also you can see very little amount of the water body. Okay, then vegetation and barren land. Okay, so we also calculated the all of the each classes area in hectare unit, as well as also make the chart like this in Google Earth Engine platform for the visualization of the area. Okay, so in this time I simply open my slide, I simply open my code editor. Okay, so this is the code editor. So in this time first of all I step by step I complete all of the tasks. So first of all I need to import my shapefile, which area I want to make the land use and land cover classification map. So I simply go to the asset tab, and here I already imported my shapefile, and I also try to show you that how you can easily import your shapefile in the Google Earth Engine platform. So you already covered this part. So in this time I simply import the shapefile. Suppose I want to make the land use and land cover classification map for, suppose I want to make the for the Dhaka city. Okay, so I simply import the Dhaka city. Okay, so Dhaka city shape file I want to show. I can see I simply put the name is that, suppose ROI. Okay, you can put any name. Then I simply show the layer as that map dot add layer. My object is that ROI. I want to focusing map dot center object ROI. Okay, so now I can get the map of shape boundary shape file of Dhaka city. I want to make the land use and land cover classification map for this area. Okay, so my first step is the done. I import my shape file. Second step is that you need to filtering and choosing your image collection. In this time I want to work with the land set, because I already show you that how you can easily filter the land set. Okay, so today's class I also try to show you that how you can easily filter the sentinel. Okay, then when you want to learn the how you can easily filter the sentinel, then the same process, you can just filtering the sentinel imagery for your region, and then you can using the image for making the land use and land cover classification map. Okay, so in this time I simply try to show you the land set imagery. So I simply go to the browse data catalog. From this I simply select the click on the land set. I'd work with the land set 8. Then I simply click top order. I want to work with the top of atmospheric. In this time I want to work with this satellite imagery and make the land use and land cover classification map for this region. So first of all, I simply import the image collection. I simply copy this ID and then paste here. Okay, and then I simply put a variable name in here. Suppose L8. Okay, so now my image collection is stored in my L8. So now I want to filter. So I can simply take a variable name and give the variable name is the image. So I already discussed about that, how you can easily filter the image collection. So in this time I simply write the code. I want to make the land use and land cover classification map for year of 2000, suppose 2015. Okay, I simply put it at the 2015 December, sorry, 15 January, 1st January from 2015 December 31. Suppose in this time you can see, suppose I want to get how many images I want to get from here. I want to check it. So you can see I can get how many images I want to get from here. Sorry, so I need to use here the parenthesis, then click to the run. I get total 5 images. So in this time, suppose you want to work with only for the single image, and this 5 image is not capture, or this 5 image acquisition date is not the same. Okay, so you can get all of the single image. Okay, so if you want, you can also use the single image, a specific time image. Okay, but in this time I want to create the median composite using the total 5 images. So that's why I simply use here the median function, and then I simply clip with my shapefile. Okay, if you want, you can also use a single image, no problem. So in this time the both of things will be same process. Okay, when you want to work with the single image, the same process. When you want to work with the median composite image, the same. So in this time I want to show my result. So I simply use here the map dot, I want to add a layer of the satellite image. Okay, but I did not add the visualization. I simply add the visualization from here. I want to add here the true color composite B4, B3 and B2, increase the 98% and then apply for better looking. Okay, okay, so this is our satellite image we can get from the satellite image. So in this time I simply import. Now you can see a new line code where I simply copy and then simply paste after the object. Okay, so now it's set with my code. So in this time my second step is done. So I get the satellite images. In this time I need to collect the training point from the satellite images. Okay, so I get the satellite images. In this time I need to collect the training point from the satellite images, and for every individual feature or every individual classes. Okay, so in this time when you want to collect the training point, if you want you can use here the marker. Okay, if you want you can also use here the different types of shape, no problem. Suppose you want to take this and simply take the training point from this. Suppose this training point is for water body, you can get the training point pixel value for the water body from here. Okay, or if you want you can also use here the marker. Okay, and you can simply, suppose you want to delete this, you can simply click on here and then delete, then it's also delete. Okay, so in this time I want to use here the marker, and then I simply you can see I simply click on the edit property layer. As first of all I want to take the training point for the water, so I simply put the name is that this is the water, and then I simply put here the feature collection. Suppose property, properties is the same, property name is the same for all of the classes. Okay, so I simply put the property name is that class and set the value is the 0. Okay, so I want to start the value from the 0. So it means that the property for the water body, all of the training point, this value is the 0. Okay, so in this time here you can see I simply click to the OK, and then you can see water. Okay, you can see first of all I simply select the water. Okay, when I select the water you can see it look the bold black color. Okay, so I see when it bold black color, then I simply take this training point from here. Okay, so now you can see here I just simply take the training point for the water from here. So I just simply take the training point from the water body from this satellite image. Okay, and then I simply take the another, suppose I want to take the training point for the build up area or urban area. I simply click the new layer and then go to this again in here, edit layer properties, and then I simply put the, suppose this is the, suppose urban, okay, or build up area, you can use anything. I simply use here the feature collection, then property, and put the property name is the same for the class. Okay, you can use any name as a variable, but which name you want to put first, class, you need to same all of the class. Okay, then I set the value for the urban 1. So all of the training point for the urban, it's showing the 1. So I simply click to the OK, and then I simply take the training point from the urban. You can see now it selected the urban. Okay, so I simply take the training point for the urban. Okay, and then I simply take the another, suppose new layer, simply click here. In this time I want to take the training point for the vegetation. So I simply use here the vegetation, and then I simply set the feature collection is that property is the same for all of the classes. I simply class and I set the value for the vegetation is that 3, sorry, 2. Okay, so 0, then 1, then 2. Okay, so sequentially I put, you can see 0, first of all 0, then 1, then 2. So vegetation. So in this time you can see I want to use here the only for the one band combination. It's called the true color composite. Okay, but if you want, you can use the different types of band combination for identify the different types of feature easily. So we can easily use the different types of band combination. You can simply go to this link. From this link you can get the information about the different types of band combination. So basically you can see basically when you want to use the different types of band combination, and different types of band combination is help to identify the different types of feature in that surface. So here you can see the different types of band combination. Suppose you can see this is the one kind of band combination 432. In this time I use the band combination red, green and blue band. So it's the totally true color composite or natural color. It's also called the true color composite. Basically it showing that human eyes can see randomly. Okay, and in this time when you want to use the band combination, you can see the healthy vegetation is the green, unhealthy flora is brown, urban feature appear with the white and gray, and water is the dark blue or black. Like this result we can get when you want to use the band combination. And when you want to use the band combination 543, it's called the false color composite. So mainly we are using this band combination for the analyzing the vegetation on the surface. So basically you can see this band combination is useful to analyzing the vegetation and particular area when you can get the red. Okay, red have the better vegetation or healthy vegetation. Okay, red pixel value, better vegetation or healthy vegetation, and dark areas are the water and urban areas are white. Okay, when you want to use the another shortwave infrared 764 this band combination, okay, then you can get the displays the vegetation in the shade of green, while dark the shades of the green indicate the denser vegetation, especially in the lighter shades, and urban areas are the blue and soil have the various shades of brown. Okay, So when you want to use the when you want to identify the agriculture cropland like this feature, so then we are using the 652. Okay, so mainly it's commonly used for the crop monitoring. Okay, and healthy vegetation appears the dark green, but the bare earth is the magenta hues. Okay, so it's also when you want to identify the barren land, then it also help. Okay, this combination. Also you can see geology when you want to identify the any geological feature, bathymetric. Okay, lot of you can see vegetation index. Okay, nor NDVI. So basically previous class also try to show you that how you can easily work with the NDVI and using the satellite images, and when you can get the pixel value for the high positive pixel value is identify the high vegetation or dense vegetation. Okay, where the negative pixel value is identify the there is the no vegetation. It can be water or a rock or barren land like this. Okay, so in this time you can easily use the any band combination and you can easily identify the different types of feature. Suppose in this time I want to work with this feature 543, so I simply select here, suppose band combination, this is the 5, then 4 and 3. Also increase the strength 98%, then simply click to the apply. So in this time here you can see you can easily identify the red color pixel value, identify the dense vegetation in here. So in this time I want to collect the training point for the vegetation. I simply select the vegetation and then I simply take the training points from the red pixel value for as a vegetation area. Okay, so I simply select. As I simply take the training point for the vegetation. Okay, in this time I want to work with the suppose barren land. I simply take the another class and then put the name is that suppose barren land. Then I simply put the feature collection and property name is the same for the class, and value I set the 3. Okay, then click to the OK. So in this time I simply take the barren land. Suppose in this time I want to work with the band combination for 652. I want to work with the 652. So I simply select here the 652, 6, then 5 and 2 and click to the apply. So now I can easily identify where is the brown color. It's identify the barren land or fallow land. So I simply take this from here, so you can see. So I select this and I simply take this brown color like this as a barren land. Okay. Okay, so my third step is done. So I simply take the training point. You can see water, urban, vegetation, barren land. I want to classify the water, urban, vegetation and barren land. I simply take the training point for all of the classes which I want to classify from the satellite images. In this time, I just merge all of the training point together. I just merging all of the training point together. So it's very easy. So I simply take a variable. Suppose the variable name is training. I simply put the variable name as the training. Okay, and then I simply merge all of the training point together. So in this time here you can see, first of all I simply put here the water. It merge with, suppose merge with urban. It merge with vegetation, merge with bare land. Then this time I simply merge all of the training point together and store it all of the training point in a variable training. So I simply use here the print function and then I simply call the training. And click to the run. So now I can get all of the information about this training dataset. You can see into the console tab. Here I can get all of the information. Here I can get total 94 training point, all of the classes. Okay, and you can see all of the training point. It will be start from the 0 up to the 93. Okay, so all of the training point I can get. In this tab you can see, suppose this 23, this number of training point you want to check, what is the, you can see this 10 class 1. So this 23, this number of training point is the class 1. So it means that this training point I want to collect for urban. Okay, so when I want to set the urban, you can see I want to put the value is the 1. Okay, so suppose I want to check the another, suppose 64, what is the training point for I collecting? I collect the training point for the class 2. So what is the class 2? Class 2 is the vegetation. Okay, so all of the training point I also get also their class. Okay, class 3. Okay, so you can see here I can get total 94 training point. Okay, in this time I generate all of the training point. For each training point I generate the spectral signature values or bands values. Okay, so I want to take the band for, and I want to create it the band value for each training point. So here I can get the total 94 training point. So 94 training point I want to create it for all of the band value. Okay, so in this time, so for this I simply take a variable. Suppose this variable name is the bands. Okay, and then I simply make a list all of the band, which band I want to create it from, which band I want to create it from the band value or a spectral signature. So I simply put here the, suppose B1, then B2, B2, then B3, then B4, red band, then near infrared band, then short wave infrared 1, 6, as well as. So in this time here you can see I select this band. Suppose you can see for the training number 0, for this point I want to generate all of the band value. For this one, for this point I generate all of the band value. For the point 2 I want to generate all of the band value. So every individual point or every individual training point I generate all of the band value which I want to put in here. Okay, so in this time I just simply add this band, all of the band I simply add with my image. If you want, you can simply use the select function, select, and then you can simply use here the band name. Okay, so it's okay. If you want, you can simply select and then simply copy the name, because this variable is total of the things. In here you can simply paste. Okay, now all of the band is set with my image. Or if you want, you can also do for the another thing is that I simply take another variable, suppose input. Okay, then I simply call my image. I simply call this image. I simply copy the variable name because this variable is stored at my image, and then I simply paste here, and then I simply use here the select function, select my band. All of the band is stored in this variable. I simply copy and paste here, so it's also okay. So in this time my final output is that input variable. This input variable is stored with my image with a specific band which I want to select. And what is the image? I already filter my image, all of the things, and store it in the image. Okay, and then I simply select all of the band which I want to add here. In this time I want to do this. In this time I want to take the another thing is that I want to create a variable and give the variable name with the suppose level, and in this variable I want to put my property name. What is my property name? Class. Okay, I simply copy the property name from here, and then I simply paste here property name. So in this time I simply generate or created the band value or a spectral signature band value I want to create it. So for this I simply take a variable and give the variable name is that suppose train image. Then I simply call my input image. So input is that you can see this variable is stored at my image with my specific band. So which band I want to generate the band value. So I simply call the input. I simply paste here. I simply use a function, this function called the sample regions. So sample region is a function mainly when you want to extract the band value, we want to use the sample regions. So in this time I want to extract the band value, so that's why I simply use here the sample regions, and I simply get all of the argument. I simply make a dictionary. I simply use here the curly bracket start and curly bracket int, as well as in this time collection. So collection is the keyword, and this key value is that training point, and all of the training point is stored in a variable. This variable name is the training. I simply copy and paste here. Okay, then properties. So properties is that you can see when I want to collect the training point, I simply put the property name. Property name is the label. I simply use here the class. Property name, you can see property name is the class, but this class I store it in a variable and put here label. Okay, I simply copy the label and paste here. Okay, then scale. Scale is the resolution of your satellite imagery. So in this time Landsat 38 meter, 30 meter. Okay, so I simply remove, it's not important, I simply remove. So now you can see it generate my training point or spectral signature value or band value for every point. I simply print this train image and then click to the run. So in this time here you can see all of the band value for every point. I simply click to here and go to the feature. Suppose you want to check for the 0 number point, what is the band value, all of the band value. I simply click to here. Here you can get the properties. Here you can get, I can get all of the band value for the 0 number point. Suppose at this point you can see all of the point, you can get the all of the band value b1 2 3 4 5 6 7. So you can see all of the band value you can get, all of the band value you can get. So in this time we generate our data set. So this is our data set. In this time I want to run my model using this data set. Okay, so that's why I want easily classified these satellite images. So in this time here you can see you can get the band value. Okay, all of the training point get the band value. So in this time when I want to just generate the run my model, in this model I want to, suppose you can see for the water body. So for the water body it extract the band value. Okay, it extract the band value for the water, and when this water band value is the missing with the other feature of these images, it automatically predicted this is the water. Suppose you can see urban area, I want to take the training point for the urban area training point. So training point means that this training point is it's generate or produce the band value. Okay, so all of the training point created the band value. When this band value is same with the other feature of the satellite images, it automatically identify this is the urban area or build up area, and do for the same for the barren land. When it take that training point or it take the band value from the all of the band value, when this band value is the similar with other properties or other feature of the satellite images, it automatically identify this is the barren land. And same is the for the vegetation, it take the training point for the vegetation from here. When this vegetation band value is the similar with other feature of this images, it automatically identify this is the vegetation. Okay, so in this time I want to get my data set. Okay, so in this time my full data set is stored in a variable train image. Okay, in this time I want to use here from the data set, I want to use the some data for, I want to use the 80% data for train my model and 20% data for checking my validation or check my model is the good, or accuracy for the checking this model is the good or bad, I want to check it. Okay, so for this I want to simply take the data in the two way. Suppose I want to in this time, this is my full data set. Okay, this is my full data set. This data set I want to divide into the two way. I want to use the 80% data for train my model and 20% data for check my validation. Okay, so in this time I want to do this for this. In this time I simply, okay, so I simply take a variable, then I simply call the variable name is the, suppose train data. This train data is that I simply call my train image because this variable is stored all of the data set, and then I simply use a function, it's called the random column. So random column is a function. In this time here you can see, here I can get the 80% data and 20% data from this data set, but I want to take the data set randomly, not selectively. Okay, so I want to take the randomly 80% data and 20% data for checking the validation and 80% data for train my model, and it happened that randomly, not selectively. Okay, so that's why I simply use the random column function and stored all of the data set randomly in the train data. In this time, this train data I divided the two way. I want 80% data for check my train my model and make the classified image, and 20% data for checking my validation. Okay, so in this time, if you have any question or any doubt in this code, you can ask me. Hello, can you hear me? Hello.
Yes, sir.
Okay, so some networking issue, so I disconnected. Okay, so if you have any question, you can ask me about this code or any doubt. Then we move to the forward for divided the dataset the two way. For the some dataset we are using for the check by model, and some dataset for using for the train our model. Okay, so 80% data and 20% data. So I hope you can got the point about the dataset. So in this time, I try to show you that how you can easily divided the dataset for 80% data for train your model and 20% data for check your model is good or bad. Okay, or
Sir, I have a question.
yeah, any question?
Sir,
Yeah.
what you have done is you select some spectral band and you converted them into a legend. But if I have some international standards of a unit like I have to put methane and a value of different gases according to international norms. So how can I do that with their legends, with their value of legends?
So in this time you want to ask about the band value, yeah?
Yes, sir.
Okay, so basically you want to see the different time you are using the different types of band value. Suppose if you want, you can also add here the some external band value. Suppose you want to external band, suppose you want to use here the ndvi band. If you want, you can also use here the ndwi band. If you want, you can also use here the different types of band for get the band value. Okay, so it's mainly yeah.
Sir, to be more precise, if I want to show the value of PM 2.5 and PM 10 according to international norms. So, can you tell me from where I can get the spectral band value of PM 2.5 and PM 10, and how can I
Okay,
put
okay.
that
So
on
PM, I already sent you this. So this topic is in land use and land cover classification. So this is the air quality monitoring part. Okay, so PM 2.5 you can get the from the MODIS. Okay, MODIS
Okay.
optical Landsat. I already send you the data set for the MODIS, and also prefer you the research paper for the MODIS. So you can also, if this code I already developed about the using the MODIS, but PM10 is not available in this time. So that's why I also try to find out the algorithm about this. Okay, so what is the algorithm? If you have any algorithm about this, you can also send me this algorithm. Then I also try to work with this. But which paper I already send you for the PM 2.5. So I already developed this code in my code editor. So PM 2.5 is no problem, but PM 10 is not available in my here because I did not have any more algorithm about this. Okay, so that's why when I want to make this, I also need to
I have a
learn
research
study
paper.
about this. Yeah.
I have a research paper regarding PM10. Can I send you?
Okay, no problem. You can, after completing this class, you also send me this. I also check this and try to develop the model. No problem.
Okay, okay. Thank you
Okay.
so much.
Okay. So in this time, here you can say I can get the data set. So in this time, I want to just divide the data set into the two way. Okay, 80% data and 20% data. If you want, you can also use that the 70% data, 30% data, no problem. Okay, so I want to use here the 80% data and 20% data like this way.